Alrighty. Well, it's 8 o'clock. Woo, feels like forever since I've seen you guys thanks to that holiday.
Yeah.
Good boy, but that means that the final is so much closer. Oh, so much closer. Shoot, what day is it on? Is it like a Tuesday or something?
Next Thursday.
Thursday? Yep, so I'm going to be able to get plenty of questions answered right away. I got a bunch of emails after sending out that announcement about SI sessions this week. So I'll try to get all these answered right now. One, from this point forward, we're going to be focusing on this practice final. As you guys have seen, this thing is humongous. So a lot of this you guys already know right off the bat, so most of it you guys shouldn't have any problems with. But a lot of the practice problems he gave you guys, there are some examples of those exact types of problems in this practice final. So I feel like covering the practice final will be more beneficial for you guys. Second question that I also received, will there be SI next week? And technically SI is supposed to end this week, technically. But I was able to work a little bit of magic, and I should be able to host 3 additional sessions next week as well. So, yes, SI will be back next week. And again, we'll cover more of the practice final, because we're probably not going to be able to get through this whole thing in 3 sessions, let's be honest. So yes, there will be SI next week. I'll post the dates and times near the beginning of the week like I usually do. But yeah, so we've got from now until Thursday to prep for this final. Now most of this stuff you've seen, but now there are some reactions and some reagents you guys are a little less familiar with. So I'll try to hit those and try to explain as best I can. But alrighty, any other questions about the final SI before I begin? Mm-hmm. Let's see, Wagner's hosting one on Saturday. I sadly will not be at that one. Sadly, no. Saturday is the only day off I get, and as much as I love the OChem, I will sadly not be here for Wagner's review session.
You deserve some me time too. I said you deserve some me time too. It's okay.
Yes, I have a soul. I need some time to myself, and that is the only day I get considering I work Sundays. So the only day I get Saturday. So you're on your own with Wagner on that one. Not that that's a bad thing or anything. But all right, let's. Any other questions though before I start? Any other questions? Thoughts, concerns? Alrighty, let's dive right into this. Now, first page, obviously it's nomenclature, but this is not just any nomenclature. This encompasses everything. This encompasses basic nomenclature. It encompasses alkenes, alcohols, everything that you guys have learned so far. So I'm going to go through these, even though they may look very obvious. Some of these have some, like I said, some slight changes to them. So look at the first guy. All right, so we got 2-chloro-2-butene. All right, so what's our longest carbon chain here?
4.
Right? The but part tells us that's going to be a 4-carbon chain, and what does the ene tell us? That this is an alkene, that there's a carbon-carbon double bond in it. And where specifically is it? At the 2-carbon, right. So we can get from this back half of this here that we got a 4-carbon chain that has a double bond basically sitting in the middle of it. So I'll just draw this guy out. 4 carbons long. 1, 2, 3, 4. So 2 to 3, that's where our alkene is going to be. Makes sense so far, right? Nothing too terribly complex so far. And then what does this tell us? Yep, then we got ourselves a chlorine, and it's sitting also at the 2-carbon. So if I numbered it 1, 2, 3, 4, or 1, 2, 3, 4, doesn't really matter which direction we name. We put the chlorine right there. And that's it. That's all there is for this guy. And now, what does the E in the front of the name tell us? So what is the E indicating to us? Or has he not covered this guy yet?
I can't.
So there's cis and trans, right? You guys are familiar with that, right? E and Z are the other 2 ways you can indicate cis and trans configurations. Where you have cis and you have trans. Now E, if I remember correctly, E is the equivalent of trans, and Z is the equivalent of cis. It's another shorthand way of writing cis and trans, using, again, less letters. So the E just tells that we have a trans configuration here. So that means our highest substituents on both sides of the double bond have to be trans with respect to each other. So the highest substituent on the 2 carbon is this chlorine over here. On the other side, we do have a hydrogen here that's not drawn. It's this methyl group. So notice how the 2 highest substituents are trans with respect to each other. And that's all the E is telling you, is that you've got a trans configuration. So in case you guys weren't familiar with that, just remember that. E is trans, Z is cis. And to shorten it up, you have trans Z and cis Z. Something silly and random to remember it by. But does that make sense so far? Any question on that first nomenclature one? Like I said, that's a loaded one right there, right off the bat.
Does it have to be in that shape, or can it be like a zigzag like before?
It could be the other way. So you could draw it, theoretically speaking, you could also draw it this way. And you could toss the, let's see, you could theoretically toss the chlorine on this side. Yeah, actually, now that'd be cis, so you have to throw it this way. So you could also draw it this way. You could draw it kind of upside down / inverted. As long as you've got the chlorine and the methyl on the opposite side of the trans configuration, you can draw this in just about any way you want. You can even draw it pointing this way if you wanted to, so on and so forth. As long as the chlorine and the methyl are trans, then your structure will be valid. Good question though, good question. Any other questions on this guy? Like I said, the E and the Z naming is not commonly used, but again, don't let it throw you guys off. It's just another way of saying cis and trans. Alrighty, let's take a look at the next guy. Okay, so what are some observations we can make about this? Just start shouting them. There's a bunch we can make here. Right, we have an OL here that tells us we have a hydroxyl, or we have an alcohol. What else? What else can you guys observe here? Yeah, we also have a methyl and it's sitting at the 2 carbon. Alright? What else we got? Yeah, it's the 3 carbon chain. So we have 3 times C. And the 2 tells us where the alcohol is located. So it's going to be at the 2 carbon also. So, alright, let's draw this guy out. So I'm just going to draw a basic 3 carbon chain. There we go. 1, 2, 3. There we go. So I got my propyl group, that's where the prop comes from. And we have a methyl sitting at the 2 carbon, so if I say this is 1 and this is 2, or 1, 2, doesn't matter the direction I count in this case. We have a methyl sitting at the 2 carbon, we also have an alcohol sitting at the 2 carbon. And that's it. That's all there is to it. Any questions about this guy? Pretty straightforward, right? Like I said, don't let the suffixes and the additional functional groups mess you up. It's a propyl group that has a methyl and an alcohol on it. Alright, let's look at the next guy. Oh boy, we got some fun stuff here. Alright, so we've got R4 bromocyclohexene. Oh goodness gracious. We got a lot of stuff we gotta take note of here. So we got a hexene, right? That's 6 carbons, and what does the ene tell us again? Yep, it's got a carbon-carbon double bond in it. And the cyclo? That's a ring structure. So you've got 6 carbons arranged in a ring, and you have a carbon-carbon double bond in it. Right? Now I can place the double bond wherever I want to in this case, because notice there's no number in front of the cyclohexene. That's because we assume that the carbon-carbon double bond is sitting at what numbered carbon?
1.
We're assuming that it's sitting at 1. And that's why our bromine is going to be sitting at number 4. So where we place that carbon-carbon double bond is really up to you. I'm just going to stuff it right here, just in the side somewhere. Alright? So we have 4 bromos, so we got a bromine. A bromine sitting at the 4 carbon. Now I could count off 1, 2, 3, 4, 1, 2, 3, 4. It really doesn't matter. It's again all based on how you prefer to draw it. So I'm gonna go 1, 2, 3, 4. I'll just stuff it out here. But now I haven't drawn it attached to the ring yet. And why is that? Yep, there's an R right here telling us that that 4 carbon is a stereocenter. And if we fill in the imaginary hydrogen, we see that we do indeed have 4 unique things bound at that carbon. Now we want to have the right configuration, or we want to be counting clockwise. So let's start numbering off our priorities. So who takes number 1? Bromine, hydrogen, top chain, bottom chain. Bromine does, right. So this takes number 1. Who takes number 2? Bottom chain, top chain, or hydrogen? Bottom chain. How do we know this? That double bond right there is going to give this chain more weight than the top chain. And then I will fill in the rest. 3 and 4. So what direction are we counting in? We're counting in the S direction. Do we want that? Nope. So what configuration does bromine have to be in? It's got to be dashed. Remember, we want to invert our stereochemistry here. So that means number 4 needs to basically not be in the back, which means that it has to be wedged, which we know we're organic chemists. We don't necessarily have to draw that hydrogen. We can just leave it like this. But does that make sense, though? How we drew it this way and why bromine is dashed instead of wedged? Pretty straightforward stuff, right? These should be the easy points.
What if you put like the double bond like closer to the bromine?
Ah, so what if we put this double bond closer to the bromine? So theoretically, what if we moved it over? If we moved the carbon-carbon double bond 1 carbon over, moved it closer, would the bromine be sitting on the 4 carbon at that point? Here it'd be on the 1, 2, 3 carbon, so we then have to move the bromine a carbon away, and the cycle would continue. So no matter where you place that double bond, the bromine must always be on that 4 carbon. So whatever structure you draw, it will always have bromine in this configuration, because you can't put the double bond any closer, and you can't move it any further away. It has to be sitting there at that 4 carbon with respect to the carbon-carbon double bond. Any other questions on this guy? Any other questions on the ring, on the ene, on the bro? Any questions on this guy? Alrighty, solid, solid, solid. And now, oh goodness gracious, this guy. This is the guy I'm sure that's probably gonna stump everybody because one of these functional groups is gonna get misplaced. But let's try to break this guy apart and try to avoid putting the wrong things in the wrong place. All right. So again, we start out with our carbon chain, right? So what is it? It's a cyclohexane. So it's the exact same thing that we had in the previous drawing. But now is there a double bond in it? No. The ane ending tells us there is no double bond in here. So I can just draw the generic cyclohexane, or hexagon for science. So we got the cyclohexane part down. Okay, that makes a lot of sense. Alrighty, so now we identify what substituents we've got. Okay, so we have a methyl ethyl, and then we have just a plain methyl. Now it tells us here that our methyl is sitting on the 1 carbon, and the methyl ethyl is sitting on the 4 carbon. So again, numbering here is strictly up to you. I like to start numbering at the top of the ring if possible. So up here, I'll say this is our 1 carbon, so to speak. 2, 3, 4, 5, 6. So there's my ring, and I've numbered it 1 through 6. I numbered it just regular clockwise. Nothing too terribly bad there. So we got a methyl sitting at the 1 carbon. So I'm going to put the CH3 up there. And then what is a methyl ethyl? What is that? It's basically the equivalent of an isopropyl group. It is just an ethyl with a methyl coming off of it. And this would be the attached group, wherever it's attached. So this guy right here